All right, guys, welcome back. Good morning to day 2 of lesson 9.7. So yesterday we started lesson 9.7. We looked at law of sines. Today we're going to finish it up by looking at law of cosines. And I already have the notes started for us. I'll post my answer key to Google Classroom, but please take notes on your own. It helps you retain the information, okay? So we're going to use law of cosines to solve a given triangle. Again, what does it mean to solve for a triangle? It means to find all the missing angle measurements and side lengths. Okay, so you can use law of cosines when you're given two sides and an included angle. So that's going to be our SAS example that we're going to look at. Or you can solve the triangle when you're given using law of cosines and you're given three sides, side, side, side. Okay, the three formulas for law of cosines are listed below. And I'll explain how to determine when to use each one. But I'll just read the first one for you. A squared equals B squared plus C squared minus 2BC cosine A. Okay, so since the A, side A, is basically isolated, it's not completely, there's still that square there, but since it's basically isolated, this is the formula I would use if I was trying to solve for side A. This formula would be used if I was trying to solve for side B, and this formula would be used if I was trying to solve for side C. Now, if I was trying to solve for the angles using law of cosines, since angle A is part of that first formula, this formula would be used to solve for angle A, this one if I was trying to solve for angle B, and then this one for angle C. Okay, so let's jump over to the first problem we're going to look at today. We're going to use law of cosines, and this is our side angle side example. So you can see the given triangle. I labeled the two sides, 14 and 11, and the included angle is 34. Now, if I was going to try to use law of sines from yesterday, it wouldn't work because there'd be too many unknowns. For example, sine of 34 over B is equal to sine of C over 14. Two unknowns, side B and angle C. Or if I tried to use angle B and angle A. Well, angle A is unknown and side B is unknown, so still two unknowns. So law of sines will not work at this point, which means I'm going to use law of cosines. Since I don't know side B, I'm going to use this formula here. So let me copy that down. So I have B squared is equal to A squared plus C squared minus 2AC cosine B. You're going to substitute in all the values you know. So B is what I don't know. So B squared is equal to 11 squared plus 14 squared minus 2 times 11 times 14 cosine 34. All right, we'll clean this up a little bit before plugging it into our calculator. So I have B squared equals 121 plus 196 minus, when I multiply, I get 308 cosine 34. Okay. From here, I am going to just plug it into my calculator and simplify that right-hand side. So let's do that together. 121 plus 196 minus 308 cosine 34. I'll show you. And you get 61.6564, blah, 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 blah. So B squared is equal to 61.65642765. So to get B by itself, I have to take the square root of both sides. So B is going to equal the square root of 61.65642765. All right, we are going to approximate. So in my calculator, I'm just going to do second. Oh, nope, I pushed the wrong button, sorry. Second x squared. Then go up and grab that decimal and bring it down. Push enter again. And you get approximately 7.9. So B is approximately 7.9. 7.9. Okay. So now I need to solve for either angle A or angle C. I need both of them, but pick one. I could, again, use law of cosines, right? And I would use this one if I wanted to solve for angle A. I would use this one if I wanted to solve for angle C. But the law of cosines are kind of clumsy equations, right? They're kind of big. law of sines are much easier to remember, write down, and use. So even though I normally say don't use approximated values to find other values in the problem, for these examples, it's okay. All right. So I'm going to set up a law of sines problem like we did yesterday. Sine of b over b, I know both of those, is equal to sine of a over a. That'll allow me to solve for angle A. Or I could choose to solve for angle C. Sine b over b is equal to sine c over c. So you pick. I'm going to solve for angle A. So I'm going to set up sine b over b is equal to sine a over a. So I'm going to have sine 34 over 7.9 is equal to sine a over 11. You could do cross products if you look at this as a proportion, or to isolate sine a, just multiply both sides by 11. So now I have sine a is equal to 11 times sine 34 over 7.9. To get a completely by itself, I have to take the inverse sine of both sides of the equation. So a is equal to the inverse sine of 11 times sine 34 over 7.9. And that is what you're going to plug into your calculator. Okay, so inverse sine, I'll show my calculator in a second. 11 times sine 34 over 7.9. And you get approximately 51.1. Okay, so A, the measurement of angle A, it's approximately 51.1 degrees. Oh, there we go. So I'll come over here, 51.1 degrees. Now I could absolutely, again, use either a law of sines or a law of cosines to solve for angle C, but the easiest part, or the easiest way to figure out C at this point, is add those two, subtract from 180, and you'll get 94.9 for that missing angle. Okay? So I just have one more example to show you guys using law of cosines again, but a side example. So let me get that set up. All right. So this is our side example. Our triangle is going to look like this. Angle C, angle A, angle B. So that's side B, side A, side C. And the given is all three sides. So the given is that side B is 27, side C is 20, and side A is 12. Okay. So again, if I tried to use law of sines, it wouldn't work at this point because there's too many unknowns, right? Sine of B unknown over B is equal to sine of A unknown over A. Two unknowns, okay? Or if I tried to use C instead. So I have to use one of the cosine problems. So you can pick. If you want to solve for angle A, use this formula. Solve for angle B, use that formula. Solve for angle C, use that formula. It's up to you. I'm going to solve for angle B, so I'm going to copy down that first equation. All right, so I have, or not first one, sorry, second one. B squared equals A squared plus C squared minus 2AC cosine B. And you're going to fill in everything you know. So 27 squared equals 12 squared plus 20 squared minus 2 times 12 times 20 cosine B. Running out of room. Okay. Cleaning up and simplifying it a little bit, I have 729 equals 144 plus 400 minus 480 cosine B. All right. When you add and subtract to the other side, you're going to be left with 185 is equal to negative 480 cosine B. Let me try to get a marker that's not dying. All right, and then after that, you're going to divide both sides by negative 480. I don't think this one's much better. All right, after you divide both sides by negative 480, you're left with cosine B is equal to negative 185 over 480. Now I could simplify that fraction, but I'm just going to end up plugging it in my calculator, so I'm not going to bother. To get B by itself, take the inverse cosine of both sides. So B is going to equal the inverse cosine of negative 185 over 480. So you're going to plug that into your calculator. All right, so it's the inverse cosine, I'll show my calculator in a second, of negative, don't forget the negative, make sure you use the negative button, not the minus button. And you get 112.7 approximately. So the measurement of angle B is approximately 112.7 degrees. Okay, so 112.7 degrees. Now, you could absolutely use another law of cosines to figure out angle C or angle A. But at this point, now I have enough information to flip back over and use law of sines. That's what I'm going to do. Sine of B over B is equal to sine of A over A, or sine of B over B is equal to sine of C over C. I'm going to solve for A, so it's going to be sine of B over B is equal to sine of A over A. So I have sine of 112.7 over 27 is equal to sine of A over 12. You're going to multiply both sides by 12. Okay, so sine of A is equal to 12 times sine of 112.7 over 27. And then take the inverse sine of both sides. So A is going to equal the inverse sine of 12 times sine 112.7 over 27. Okay. All right. So plug that into your calculator. So I have the inverse sine of 12 times sine, wrong button, sine 112.7 over 27. And you should get 24.2 approximately. All right, so A is about 24.2. And then once you know that A is approximately 24.2, instead of using law of sines or cosines, the easiest way to solve for C is add those and subtract from 180, and you get 43.1. And I'm done. As soon as you know all three angle measurements and all three side lengths, you're done. Okay, so that is it for today. Jump on over to Google Classroom to see what your homework assignment is for this evening, and I'll see you guys tomorrow. Bye.